So I'm Jerry Wiedenfeld, and John, Sue here at Milwaukee. We're going to sort of tag team together and give a little presentation about ModelCertainty. So some background with ModelCertainty. It sort of started with actually my WCM and a forecaster here. The WCM was curious about being able to provide some temperature information to our shelters in the Milwaukee area, and he wanted it to be a probabilistic thing. So he wanted to be able to say what the probability of the temperature being 20 degrees or less would be, and then even a 10 degree or less. They had some, different thresholds that they were interested in. So that got me thinking down these lines. And at the same time, actually, this was the winter of last year, I believe. There was another forecaster here that was curious about wanting to see sort of a summation of the storm total snow from all the models. So I, thinking of those two things, that's sort of how this was born, because both are dealing with probabilities and dealing with the ingest side of bringing everything together and being able to easily see it through the GFE interface. So with that, I'll jump right into the rest of the presentation. So before I get into ModelCertainty, I wanted to do a quick yawn session on a statistics review. Some of these things may seem easy. Obviously, the mean, that's just the summation of the distribution divided by total events. Throughout ModelCertainty, this is used in a number of places. It's used as an output variable. You can see that. It's also used whenever users decide to select an edit area. So rather than having to show each individual grid point statistics, I take the sum of the grid points in the edit area and utilize that to give one actual value, the sum and the mean. The mode, that's actually a pretty important thing. It's not necessarily as important to ModelCertainty, but I wanted to hit this one because it's really important for the PWPF experiment. The mode is the most common occurring event, and that is what our forecast is in the models and the PWPF experiment. Not a lot of people, I think, understand that, and it has pretty big implications on how the PWPF is handled. And ModelCertainty can help with this because ModelCertainty is the models going into it are basically a subset of what you see in the PWPF. So say, you're looking at a system and your ranges in the 10th and the 90th percentiles just seem way off. Well, one of the reasons for that may be that you actually have a bimodal distribution, and our blended forecast is a third mode in this distribution. So it's on neither end of what the models are saying. It's somewhere in the middle. And what that can do is it can really mess up your 10 and the 90th percentiles and cause lots of problems. We've seen this here in Milwaukee. It is one of those things that just sort of happens. So the mode is something that's really important. And one of the latest additions to ModelCertainty is I've added PDFs where you can start to see some of these bimodal distributions and make good decisions on your forecast process on that. So another one here is median. This is the 50th percentile of the distribution. It's the middle number. If there are two numbers that aren't, like if it's an even distribution, it would be the average between those two numbers. Variance and standard deviation, they're sort of related. They're both measures of spread. The variance is the average of the squared differences from the mean, and the standard deviation is basically sum all those up and take the square root of that. Standard deviation is one of those important things. You can do lots of estimating of what the a normal distribution would be if you have a standard deviation. It's a good idea of what the overall spread of a distribution is. So if you have a high standard deviation, you can pretty much assume that you're going to have a pretty big spread in the overall models. So jumping into a little bit more detail here, I'm going to actually start on the bottom of this slide since I was just talking about standard deviations. there's an important rule that's out there, and it does relate a little bit to what happened and why they chose the percentiles that they chose in the PWPF experiment. So you have the 68, 95, 99.7 rule. So basically, each one of those numbers refers to a standard deviation. So one standard deviation from the mean of a distribution covers about 68% of that distribution. 2 is 95%, and 3 is 99.7. So if you have a value that is falling more than 3 standard deviations, say 4 standard deviations, that's a pretty extreme outlier. It's way on the edges of your model distribution. And then just, some more sort of background information with the PDF, and there's sort of 2 definitions for what a PDF is. You can have a probability distribution function or a probability density function. The probability distribution function is sort of like that encompassing definition. It can be both a density or mass function. The probability distribution or probability density function is usually for continuous variables, whereas a probability mass function is for discontinuous variables. So in here, I call it a probability distribution function in ModelCertainty, and that's because we can have both sort of these quasi discontinuous fields like QPF and POP and RH, and so I just decided to call it the overarching probability distribution function. So getting in a little bit more here, and these are probably some information that you might be somewhat familiar with. You have the cumulative distribution function, which is basically, it's the area under the PDF. And another way to look at it is the PDF is a derivative of the CDF. And when you're looking on a graph, usually on a CDF, the y-axis would be a percentile. So that's, we're usually saying like the 80th or 90th percentile. A quantile function, this should be something that, while it might sound new maybe to some of you, it should be near and dear to your heart. It's what we see every day in our POP. You take the inverse of the CDF, and it will give you the probability of, say, greater than 100th of an inch of precip. That is, in fact, part of a quantile function. So you just basically flip the CDF on its head, and you can get those numbers. And this is used a lot in the ModelCertainty program. It's one of the nicer features because you can get the probability of any threshold that you want, and that is what a quantile function is. And I think I got a couple more here on some computed stats that I do throw into ModelCertainty. And this confidence interval thing, I already sort of hinted at that with the PWPF experiment. This is the 90th and the 10th. That's basically saying that's our 80% confidence interval. And in the PWPF experiment, that is the max and the min of the experiment. So when we're looking at those percentiles, that's actually saying that based on the model distribution, there's an 80% chance in a reliable distribution that the verification, the OB, could fall within that. And there's a 20% chance it could fall outside of that. So another way to look at it is, say you're looking at the 75th and 25th percentile. That's saying you only have a 50% chance it's going to fall between those numbers. There's actually a 50% chance it could fall outside of those numbers. So that, it's another way to look at this. It's a good way to look at the spread of the distribution. If you have a big 80% confidence interval, that means you have a pretty big spread in your distribution. There's another thing to look at here is skewness. The skew is a measure of the extent to which a PDF leans to one side or another. This might give, to look at skew might give forecasters more confidence in issuing, a forecast one way or another. If they're leaning towards going on the high side, and that sort of goes along with what the skew is saying, well, then, maybe you do make that forecast go on the high side. in general, there's numbers of ways to compute skew. In ModelCertainty, I just do it through the percentiles. So I take basically the warm tail, which is the 90 minus 50, and subtract that from the cool tail. So if you have one side greater than the other, that's hinting at the distribution being skewed. Another way to look at it is if you have a left skewed or negative skewed distribution, the mean is less than the median, and it's also less than the mode. And if you have a right skewed or positively skewed distribution, the mean is greater than the median. So with all that, we'll finally jump into a little bit more details on the ModelCertainty tool itself. So ModelCertainty, it's been my sort of little pet project, so I've been making lots of modifications. If anybody here has actually looked at some of the training, I think that was on version 3.1, maybe 3.2. And since then, I've added a number of new things. So anything that I've had highlighted in red here is what is new to the ModelCertainty. So basically, ModelCertainty to me is more than just isolating targets. It's about completely understanding all of the data that you have available to you and being able to really dig into the probabilistic nature of this. You can use that then to drive your DSS message. This will become really important to us once we have the fully probabilistic NBM, because we need some way to be able to understand all of that information. And ModelCertainty is sort of that first step, the way I look at it, into understanding this data before we get inundated with what the NBM has to offer. So when we want to deliver these messages, these DSS messages, we really do need to dig into the probabilistic space of these models so that we can fully engage our partners and helping them understand the likelihood of certain events occurring. So with that, some of the other things that we have here, like I said, new to this is the PDF plots. Box and whiskers have been around for quite a while, so have the windrows. I also decided to sort of add the quantile, or the quartiles, the 25th and 75th percentile. Another new thing here I'll explain a little bit later is this forecast exceedance. This is something that's somewhat, I look at it as something to help you in the ESTF period. So basically it's going to highlight your actual forecast grids based on if they have exceeded the 80% confidence interval. It's a way to sort of train your eye into places that you might be able to look at and see, does this make sense? Is the 80% confidence interval nice and tight, or is it a wide distribution and all of a sudden I could actually be going, bonkers with my forecast. So we'll go to the next slide here. So one of the things I want to explain here is what ModelCertainty is not. The previous slide sort of explained what it is. ModelCertainty doesn't make any attempt to calibrate the data. The only calibration that is done is the data prior to the point of which it has gotten into GFE. That is what the NBM is for. That is what we have spent, millions of dollars on the NBM for, is to do that for us. ModelCertainty is just there basically to give us a very good feeling of what the models are doing in our software. It's not necessarily reliable distribution in the sense of, going 0 to 100 and, along that line, but it is an idea of how we can get at this distribution that we have at us right now. Once we have the NBM, hopefully we'll have the tools to take a look at that as well and be able to look at the, a calibrated system that way. The only other calibration that could be used in ModelCertainty is with bias correction. We have the Boise Verify software, and it's a 30-day running bias correction on those grids. We also right now have Moss Guide, which is a calibrated system, and that does help with, you know, making sure that model certainty doesn't necessarily go off the rails, or any other blends don't go off the rails. Another very important thing in model certainty is, for its stability, is the amount of models that are available to us. In those early periods, we can have upwards of 60 models actually in the data set, and when you're looking at temperature and wind speed and a few of those other variables. But you know, some of the other variables like max TW aloft, there are very few models actually available for it. So model certainty tries to, you know, point this out. You can see the individual models as it runs through it. And I also put a check in there for if there's less than, say, 4 models, it won't actually do any probabilistic stats. So if you're wondering why am I not getting any CDF information, or that's why. It's because, you know, you only have 4 models. Is that really something that we should be wanting to look at, that probabilistic space? All right, so here is that new GUI on the right. You'll see that there's this clear browser thing. That was a question, or somebody from the Duluth offices requested that. Sometimes they just wanted to be able to run through a lot of different elements and just keep adding that to the browser. So if you don't want to clear your browser every time, just set it to no. And as far as how it actually creates the stats, I'm using the NumPy stats package. You can get lots of good information, percentile information, max, min, mean, all just with, you know, once you've actually fetched the data and thrown it into arrays, it's just pretty much one little command and you can get all that information. It does actually compute the entire CDF. It's only outputting the 10, 25th, 50th, 75th, and 90th, but you do get from the 0 to 100th percentile in the background, and that's actually, once we have that, you can use that, create percentage grids to output, you know, certain thresholds. And again, new to this build, and it actually does require a baseline modification to the 1822 build. So this won't work even until your office gets the 1822 build, is a probability density function. So that's another, you know, another good thing that we can look at when we're trying to diagnose the spread and all that kind of information. Oh, yeah, I forgot I did this. So there I'm just sort of highlighting a grid manager. This is all of the statistics information once it fills out that grid manager screen. So there in the right you can see the average, max, and mins. And then this is some of the percentile information and spread information in yellow. And here's some of the computed stats that come out. We have the warm tail and cool tail. So if you hear me talking about that, that's the warm is the 90th minus 50th percentile. You think of that on the high side, so I call it warm. The cool tail is 50 minus a 10th. And then, as I mentioned before, you have the p-skew in there. These are sort of the percentile computed stats. That's why I have them highlighted in yellow. And then again, that 80% confidence interval will be new to this build as well. So moving on to some more stats, the probability grids, those use the CDF, the entire CDF, and each individual person, if you select that as an option in the GUI, you can select whatever threshold you want for whatever element you want. So say somebody comes to you and says, hey, I want to know the chance that we're going to have a heat index today of 100 degrees. You can run that and get an idea of the probability of that occurring. An exceedance grid, that's a grid that is only created when the max and min of the distribution. So that's sort of the outliers of the full suite of the distribution is greater than 2 standard deviations from the median. And if that occurs, it'll highlight the standard deviation grid a red color. This forecast exceedance grid That's a new one that is new to this build. This is basically looking at that 80% confidence interval. And if your forecast is exceeding that 80% confidence interval, it will, again, create this forecast exceedance grid, and it'll highlight your forecast red if the grid points, at least 20% of them are above the 90th. It'll highlight it blue if they're below the 10th percentile. And if you actually have grids that are both, this probably won't happen too often, but you know, on certain weather days I could see it happen. It'll highlight them a purple color. All right, so one of, I think, the most used functionalities of ModelCertainty is this box plot. I'm just sort of going to run through the generation of a box plot. John, after I'm done here, will do it again in live mode. But the box plot, I'm using a Python library called matplotlib. That's how the image is actually generated, and actually the statistics behind it are generated through that. So basically, I run through, I get the mean within a certain edit area. If no edit area is selected, it'll use the WFO, the whole WFO edit area, and throw that straight into this matplotlib, and it'll generate the box plot. You can do this for a lot of time ranges, all the way out to 36 times, 36 if you want. It'll put them all on one image, and it's a quick way to see your distribution. And so here's just some of the definitions of what a box plot has. Outliers will pretty much always be colored in this sort of green diamond color. WPC guide will always be blue, a blue square. Previous will always be a purple triangle. Then you have your regional blends, which will come up a green color. MBM I have on here separate, just because I felt like it would be good to have that on separate. That's going to be a green triangle. The box part of the box and whisker, that gets at your 75th and 25th percentile. The black line will always be the mean, and the red line will always be the median. I don't change that. That's just how it is. So I didn't put that into the legend. And then when you look at the sort of X variation of those dots, I just did that randomly it should be contained completely within the box. But it was done so you could actually see the variables. It doesn't really mean anything. The height is what means something. But the variation there on your x-axis, that's just done to make sure they're not all just on one line and they conglomerate. So this next plot here is just showing an example. If you selected, say, the min-t for 7 days, it'll put that all on one map or one image. And that legend that's up here on the left, that location can change based on what your box plots look like. It just puts it in a spot where it's not going to overlap the actual box plots, the data themselves. All right, so windroses. This is something that I put in here. I don't know if a lot of people have used it, at least I haven't heard that, but I think, it has a lot of good implication for aviation. You can get a good idea if you're going to have a good wind transition. So this is, again, selected by, you would have to select the wind direction. In this particular example, I didn't select any BC models because there isn't any bias-corrected wind direction. And then once again, you do the show box plot, and then you hit run, and it will bring up this windrose. And this windrose will show, it's basically SREF style. So it's counting up all of the different models for that certain time range and doing a threshold and figuring out where that model is saying for this edit area is going to say that the wind direction is out of. And the darker the red, the higher the percentage of models are. So in this particular example, you can see that there's a few outlying models that are, between the 270 and 315 and degree and 45 and 90 degree line, but the basic general idea is that it's going to be out of the north. And John, I think, is going to run through this in real time again, and show some cases from today. So then this is the new thing again, this probability distribution function. This will be new as long as you make a slight change to your 1822 baseline. I do have a NCF trouble ticket open on this, but there's really nothing I can do about it right now. The code will not break. If you don't make this change, it just won't. You won't have the option to do the probability distribution function. You won't see that new GUI option down at the bottom. So if you're not seeing that and you want to see it once you're on 1822 and have this new version installed, feel free to contact me. I'll help you along those lines. I do have the instructions in the Forecast Builder suite, but whatever. You can always talk to me. I can help you out. The idea with this probability is I had to import a new stats package. Not really new, but it's something extra to Python. It's the SciPy stats KDE package. And so once I grabbed all of the mean of each model for the edit area, I threw this into this SciPy and basically computed what the PDF would look like. And then threw that into Matplotlib. And so this next one will sort of show you an example. In this example I ran, this is, I guess, a week or so ago. I ran it for max T for 7 days. And you can really get to this feeling for all of the information that you can get out of this. What jumps out at me right away is that blue line. That's a day one forecast, so it should have pretty high confidence. So that PDF really peaks up there, and you have pretty high confidence in that one. That our temperature is going to be somewhere in that 68 to 70 degree range. You can also start to get hints at bimodality. So if you look at that green line, that's our day two forecast. There's evidently some models, in that 58 degree range that are hinting at a bimodal distribution. So maybe it's a timing issue or, bias correction type issue or something like that. And then you can also start to see that skewness. So that, I guess, puke green color and the black line, both of those are skewed, and they're skewed the opposite way. So, this was actually a pretty nice little case for me because I got to see lots of different things here. And, that's somewhat the case when you're in the springtime dynamic situation where you can really start to see lots of good information from these PDFs. And another thing you can start to see that I added to this based on request was the models that went into the distribution. So here you can see that blue line up at top, it's in the legend. 60 models went into that distribution. That's a lot to chug through, and it's a lot that we can actually start to diagnose by looking at this information. So another fun little thing, and this does again require a little bit of setup work. It's just a quick little mod to the local config and turning something on within the ModelCertainty configuration. You have to set a variable to true that you want to do image generation. We have the ability to actually create probabilistic images. We use this fairly often here, usually based on thresholds, temperature greater or less than 32, max wind gust greater than 39. Those should both be pretty well-known thresholds, and that's what I'm going to show in this example. So this was actually, I think, last week. We had some good strong winds moving through here, and you'll notice in here at the top, the wind gust grid is actually highlighted red. That is suggesting that we are exceeding the 90th percentile here in our forecast. This was, I think, on Thursday last week. We had that pretty strong system moving, and I think we even had some products out for wind advisories. So I wanted to show that grid. This is that wind max wind forecast exceedance grid here. But from that point, the next GUI that will pop up once you've hit run on the ModelCertainty GUI will be create probability images. And you'd select that to yes. And then it'll bring up another GUI to give you some flavor of how you want that image generated. This is all using the Sacramento Grid Image Maker. So here I selected that I wanted to see the max wind gust grid as well as the max wind gust probability grid. And here I chose 26 knots just so we could get some flavor. That 30 knot threshold was a little above what the models were suggesting. So the probability grid was going to be 0. The probability grid on 26, actually, you'll see here, is going to show something. So here's those images, and those are going to be automatically shipped over to based on the code, will be put into a directory on your LAN. You have to fill out some of that information. It should utilize wherever your grid image maker goes to. We have ours going to what we call the S drive, and it goes to an image directory, and that's all just shipped there automatically. So it's pretty quick. So with that, I guess we'll sort of wrap up some of the more technical and aspects of ModelCertainty. Like I said, John's going to get into some more showing of this. But the ModelCertainty tool is a tool designed to quickly access all the statistical information derived from all the data sets within GFE. Do keep in mind it does not calibrate anything. All the calibration that would be done ahead of anything in ModelCertainty. This is why we're really looking forward to seeing the MBM. I think Matt Jagaloom, he had a really good presentation a couple days ago on ensembles, and he really emphasized that point, and I think it's a great point to emphasize. The MBM is going to be a huge array of data, and I think ModelCertainty gets us pointed into a direction where we can better understand what the MBM has to offer once we get it. So the box and whisker plots and wind roses and PDF are all stored, within GFE, and can be easily created. And the big thing that I want to hit is ModelCertainty can be a driver to really help our decision support services, and add some meat to the bones for why we're saying what we're saying, and give that information to our core partners. There is some training available. It's on the CLC right now. John and I put this together. Like I said, it is, I think, version 3.1. It's pretty similar. I think a lot of what we hit on that training will definitely still pertain. So I think it's very worthwhile. It's a lot of John running through some of the examples and utility of the ModelCertainty tool. But here's our contact info. And with that, I'll field any questions that may be out there, and John will get ready to show some examples.
All right, thanks, Jerry. If there are any questions out there, please go ahead and indicate that in the interface, and we'll give maybe 20 seconds or so to see that.
And I apologize if you're hearing the drilling. We're getting getting our geothermal installed here, and so they're drilling up against our wall right now.
Nice.
It's added bonus.
All right, well, guys, I don't see any questions at this point, so if you want to keep rolling on.
Yeah, we'll start to do some examples. I've got a couple examples from today lined up, but certainly if there's anybody out there that wants to see a particular type of search, you know, go ahead and send that in to Jeff. Type that in, raise your hand, whatever it is, and we can step you through that. We want people to be able to see an example. If they're having trouble with it, we can step you through. So today, for our particular area, we got some aviation challenges. You know, the upper system has moved through. We're still dealing with some low clouds, some drizzle, some lower visibilities, not too crazy. But the big question is going to be how quickly do we improve our ceilings, which are right now in the IFR range. So I have got an edit area here over the Madison airport for today, because they're going to be one of the ones to potentially improve the earliest. And I'm just going to look at this morning and see what it looks like when it comes to the ceilings and how they're going to behave going forward. So Model Certainty is under the edit menu. Click this. There are no bias corrected cloud-based primary grids. So we're just going to do our raw models in MOS and do a cloud-based primary. We will go ahead and show box plots. We'll go ahead and show a PDF just for good measure, and we'll create some percentage grids as well to highlight areas or probabilities of being IFR conditions. So we'll go ahead and run into Smith. We'll set our threshold to be less than or equal to 900 feet, since we're looking at ceiling and IFR. And we will go ahead and let this run, and you're going to see it's going to run all the individual models. It's going to take a second to step through this, but you can see, oops, I ran it on the wrong day, didn't I? Okay, that's all right. I'll have to go back and run it on this particular day. All right, so you can see right now we're running through tomorrow morning. And it runs pretty quickly. That's the great part about this particular program, is that the way that Jerry has it programmed and designed, it runs very swiftly. So you can make very quick targeted searches on any variable that's in this list, and that is of great advantage when you're trying to look at a vast amount of information in a short amount of time. And that's exactly what this program is. It is something that organizes information, and it parses it out to give you the most important information when it comes to looking at an ensemble data set. In this particular case, I think Jerry said in the short term we have nearly 60 different data points. That's a data-rich environment in your ESTF period. Obviously, the further you go out, the more models that are going to drop off, both from a raw model, MOS, and then a bias correction perspective. So certainly in the short term, the first 24 hours or so, you're going to be looking at several dozen data sets that are going to be available to you. And certainly as you go further out in time, that becomes a little less. So here are the PDFs, and looks like we have a lot of models here this morning. We have one that's kind of out to lunch. That 12 to 13Z only has 19 models in it. Well, and this is what happens when you're running stuff between 15 and 16Z, is we're starting to get a lot of new information in from a 60 to 12Z models. But you get an idea of looking at the PDF. And then after you close that, the box and whiskers pops up. We see we have some outliers. This is what Jerry was talking about before. We have some outlying information on our 12 to 13Z time frame. But if you look at the box and whiskers, they're very compact when you look at the 14, 15, 16, 17, 18Z time frames. So let's just go back and take a look at one particular hour. What do you want to do? Let's just look at one particular hour here and show the box plot. And we'll do a percentage grid less than or equal to 900. Let's take a look at that really quick. And the box plots are obviously one way to organize that information, but you can also see the percentiles. Jerry has that now in there. You can look at the percentiles in a gridded format. So for 15Z, here's the 10th percentile over the entire domain for Milwaukee, southern Wisconsin. There's the 25th percentile. And again, we're focusing on Madison. So if you take a look, the 10th percentile is 700 feet. The 25th percentile is 900. Your 50th percentile is 1100. 75th percentile is 1400. And then your 90th percentile is 1500. So if you take a look at that graphically now, just for Madison, you can see where all those numbers come right into play here. And you can see that our official forecast is on the 25th percentile, still talking about IFR conditions. But you can see that the data set has a lean towards improving conditions. And we'll go ahead and take a look at what's going to happen over the next, say, 3 to 6 hours here. Let's take another look at that. And we won't show the individual models this time, per se, but we will show this. And we'll do the box plot and create that, less than or equal to 900. And we can show you both graphically, but then also via the box plots, when you might have improvement over IFR. So you can look at 15Z here. Probability of IFR ceilings is actually on the low side. It's about 20%. So 20% of the models are showing you IFR conditions. 80% are showing you higher. And then with time, you can see over the entire domain, the amount of area, the probability of IFR shrinking with time, so that by the time we get to 21Z, the amount of IFR is really shrinking across southern Wisconsin, which is good news from an aviation perspective. Looking at it from a figure perspective, you can get the same general trend. You have a forecast that the 25th percentile overlaps that IFR, but with time, it increases to a low-end MVFR, and it kind of stays that way going into the afternoon. We've got some good clustering of our raw models in the 25th to 75th percentile. So you know, a nice narrow 25th to 75th percentile range. It's pretty good confidence that if you have IFR at your current time frame, that the guidance is indicating with time here over the next 3 to 5 hours that you're going to be more in the MVFR category. So that's one way to parse this particular information. And if you want to make a particular image here, let's take a look at, say, this image right here. Let's create a 15Z. Perhaps you know, for where we are at here in southern Wisconsin, we have state responsibility with Wisconsin Emergency Management. And one of the things, especially after big events, be it you know, wind, tornado, flood, or whatnot, there is a high desire to get into the air the next day to take a look at damage and to get an aerial view. A lot of times the governor wants to go up in the helicopter as well and get a first-hand account of what has happened. And they rely on us to give them these types of probabilistic forecasts, you know, 18, 24, 30 hours in advance. And we can provide that information and give it to them graphically so that they can see over a period of time, you know, provide a PDF to them of all the different images that show them, you know, perhaps, you know, 12 to 15Z tomorrow may not be a good thing, but you may be able to get up early afternoon as the probability of VFR increases. So we have done that on multiple occasions. So these images, I'll just create one real quick. We'll not limit data. We'll just keep our normal domain, typical sample points, hit OK. And then I'll bring this alert visual pop-up message dialog that'll show you once that the image is created that it's been sent over to our S drive. So ModelCertainty's plugging and chugging right now. And then once that image is created, you can see it says done, creating cloud-based primary, that very long PNG file. And it's sent it to S images grid images and going over to our PC, S images, grid images, and you can see there it is. So within about 30 seconds, you can create an image from GFE that's probabilistic on a particular variable, have it sent right over to your LAN, and you can have that ready to go for an email, for your situation reports. If you have you know, some emergency manager or a particular entity that needs a particular type of image, you can create that. Go ahead and acknowledge this and get that out of our way. So, Jeff, has there been any requests yet?
I was just checking for that, and I do not see any, but if anybody out there has any, just pop one in.
All right, not a problem, not a problem. Let's go to another example that I have ready in the can here. And this is going to be more wind related, wind direction related. So we've got the potential for a lake breeze on Saturday. So I was looking ahead at the forecast there, and we'll do 12Z to 0Z, 12Z Saturday to 0Z Sunday. We will bring up ModelCertainty again. We're going to do wind direction. Since there are no bias correction grids for wind direction, we're just going to go ahead and show our box plots, and we will show the individual models. Okay, show the individual models. Jerry's directing me on that one, and we'll run and dismiss. So I actually chose the wrong edit area again. I chose Madison, so we are going to clear that out, and we're going to bring up an edit area that I brought up before, so we're going to have to, I don't even know if I want to kill this or not. We'll let it go. We'll let it go and rerun it here because it's going to run really fast. And we'll rerun this again so that I run it right along the lakefront. And that's one of the things to remember as you're seeing live here with me making the mistake. If you go by default, you don't make an edit area. Whatever your GFE domain is for your CWA, that is what the information will be run off on by default. So if you want to look at a particular area, in this case, we're going to look at the lakefront for a lake breeze. We are going to then pick this area right here that's right along the lakefront and then run the program, because that's the area we're most interested in to see if we get a lake breeze, because that's going to have impacts not only on several of our larger cities from Sheboygan down to Milwaukee, Racine, and Kenosha, but it also does affect, potentially affect our wind directions and speeds at both Mitchell Airport in Milwaukee and then the Kenosha Airport. So we'll do all this, and we'll run that again. So here is our forecast here. That's what's our forecast. You can see with time, there is a wind shift that happens right along the lakeshore as we get deeper into the afternoon. And this is the wind rose plot that Jerry was talking about. So the darker reds, and it does show up darker red on our screen, so that's good. Sometimes colors don't translate when we're using the video capture software. So you can see early in the day, it's a lot of certainty that you're going to have a northerly direction, 12 to 14Z. And then once we get to mid to late morning, now we're starting to see more of that north-northeast direction. And then by the time you get later into the afternoon, as you start to see the wind direction change, it looks like it's more centered on the late afternoon time frame. You're getting a lot more spread by the time you get to late in the afternoon. You can see some of the lighter pinks and then darker reds as the models start to shift those winds, veer those winds to a more easterly direction. Again, big implications this time of year because, of course, Lake Michigan is nothing but a big ice box. So temperatures that might be in the 50s or 60s, say late morning, early afternoon, will quickly cool down into the 40s once you get into the mid-afternoon hours, and that's quite a slap in the face for anybody who's lived along a lake like this. So this is something, again, a little farther out in time. You know, we're going about 48 hours out in time, so we don't have a lot of model information, but even the models that we do have are showing that we've got lake breeze potential for Saturday. Jeff, do we have any other any requests yet? Anybody interested in seeing anything particular?
Still nothing yet.
All right, Jerry, you wanted to show something here. Well, and I just wanted to highlight here that you can actually see these probabilities straight within GFE as well. I broke up all the thresholds, and you can see how many like the percentage of the models at the given time frames. This way, there's also a different way to sort of look at the wind direction itself, outside of the typical wind barbs. So if you click on, say, the forecast, you can sort of see a color aspect to this. So you can start to look at the MBM, whatever, and you get a good idea for actually where the winds are coming from. It's a different way to sort of look at the wind directions, but I think you can, you get an idea for the fluidity of the models. If they're all over the place, or if they're a nice looking model with their wind directions. Something I wanted to point out there.
Yeah, and that's a great point, Jerry, is that there's different ways to visualize the information, and that's what's going to be so important going forward. I think Jerry alluded to this earlier. ModelCertainty, as it's designed right now, this is the springboard into the probabilistic NBM world. We are going to have to find ways to make sense of a large amount of information in a very tactical way. And Jerry has talked about those color codes earlier, that he showed an example where some of these grids, your grids turn red or blue or purple. What those are statistically significant taps on your shoulder to potential targets of opportunity. That is the way of the database saying, hey, look at me. There's something you need to look at this time frame. There is something about the current forecast that's in there versus what's the data that's available that needs to be at least investigated or looked at more deeply. It's not necessarily you need to change anything. It's just that you need to be aware. And again, it could be something that's related to timing. It could be something that's faster or slower in the models. It could be placement. I know coming out of the winter season, there's a lot of offices that kind of pull their hair out with the very sharp cutoff of snow, no snow, where you have, within a county, literally no snow or a trace of snow in the northern portion of the county to perhaps 6 to 10 inches of snow in the southern portion of the county. How do you message that? How do you interrogate that information? How do you get the most out of what the data set is telling you? And this program will highlight those areas that are of the biggest problems for you, and areas that you're going to need to pay attention. So we talk a lot about targets of opportunity. ModelCertainty is a tool that helps you to actually visualize and define what that target is and whether or not there's an opportunity to really do anything. So Jerry, you want to do something else here? If you're going to do a run, take off your edit area. If you're going to do it over the entire area. Yeah, there you go. Don't make the same mistake I did.
I just wanted to show the quick way you can actually get a flavor for how all the models, you can see all the storm total QPF from all the models in literally seconds. So if you go down to ModelCertainty, I have our storm total QPF time range highlighted. Select storm total QPF. And again, there's no BC models for this, so I have them all off. And from there, you can just hit run. And what it's going to do is it's going to sum up all of those 6-hour QPFs for every single model and put them together, and then use that as a statistical base for creating all the probabilistic information.
I don't know how much QPF we're going to have in this case.
Well, it'll show that stuff.
Yeah.
So anyhow, get rid of this guy. So here you can just sort of, quick go through and see what all the models are saying. And, down in that southeast part by IWX's area, there's definitely lots of consistency that the models have a pretty good amount of liquid falling out of the sky there. So anyhow, even WPC's there, it's showing the same thing as is MBM.
Yep.
You can get the idea of that 80% confidence interval. So there's a little bit more spread down in this area, which makes sense because that's where the liquid's falling. But it's still pretty tight. I mean,
Bruce, did you have a question? I saw your hand raised.
Not really a question, just a comment. You know, as Jerry and John are closing out this awesome presentation, no surprise, you know, they've been at the leading edge of really promoting these types of visualization techniques to deal with an ever increasingly complex data set, and that's where we're headed with the NBM, and they've made that point so clear. You know, one thing that I would just say, which is I think is a very interesting part of the discussion here, John was talking about, you know, this giving you an alert, if you will, for possible targets of opportunity. And that's really, I think that's the brave new world here when it comes to messaging and working with these complex data sets. And I think it takes us down one of a couple roads. You know, if the data is suggesting considerable uncertainty and a target, I think it allows us, A, to consider targeted grid adjustments, potentially. Now, with time, that's going to be tougher and tougher to do with the interdependency between all the various probabilistic data that we have. But I think as much or more important, I think it affects your IDSS messaging, which I think your partners, even if there's not a single grid adjustment, it gives you an opportunity to really speak intelligently about the confidence you have in a particular forecast and or the range of possible outcomes for a particular high impact weather event. And again, Jerry and John, with you know, discussing the statistics behind all of it and then how it's used with these examples, I think has demonstrated that really well. So more than anything, I just wanted to thank them for a great presentation. I know we're not done. There's more question and answer. Folks have got them, but it's, and I know Jeff Craven and others are working on these issues as we speak, but getting ideas like this infused into the NBM pipeline for future visualization of this data is really where we're at now. So it's a brave new world, exciting times. So that's all I've got, more of a comment than anything.
Excellent, thanks, Bruce. And yes, Jerry mentioned this before, but I would highly recommend, I would say run, don't walk, run to go view Matt Jeglam's Demystifying Ensemble forecast from this past Tuesday. I think that's a seminal talk when it comes to looking at the future, how we are going to have to visualize data when it comes to ensemble information. You know, I can't sit here and tell you exactly what the world's going to look like, you know, as we continue to evolve into NBM and then the probabilistic NBM. And I think there's probably a lot of people in that same boat. But, you know, we're going to keep digging. And I think my recommendation is for anybody out there, get the old, I've got my cartoon guide to statistics book, break that out. Start looking at, you know, statistics definitions and looking at things of, you know, what do different variables mean? What, you know, Jerry kind of went over a nice rundown early. That information, that background information is going to be critical as we start to look more in the probabilistic world. It's not going to be simply looking at 2 or 3 deterministic models anymore. And with all the ensembles that are out there, all the different data sets, we have to find efficient ways to parse this information and then message it. And it all starts with going back to having a solid foundational understanding of statistics and then trying to find ways to visualize all of this information that's going to be pushed at us. So I know we're at 11 o'clock. Jeff, I don't know if we have any more time for any other questions or if there's any questions out there.
With the next session being canceled, we can go as long as you guys in the audience want. At this point, I don't see. Oh, wait, we do have a question from Jeremy. Jeremy, I'm going to unmute you.
Sorry, this is probably more for you guys. You know, John mentioned those previous talks. I can't seem to find the link. Is there a link or something you can email out to us where the previous Blue Sky talks were at?
Yes, I will go ahead and send that.
All right, thanks. You probably sent it before, but knowing me, I deleted it. So
no problem. All right, any other questions out there?
Any demo of anything people want to see? Hopefully the image is still coming in clear, Jeff. This is kind of a test on our part to see if we could get GFE to display in this manner.
Yeah, it looked great. I didn't see any hitches.
Good, that's a relief.
And it's cool too. I mean, gosh, I was doing GFE in depth 20 years ago now, so it's neat to see some of the things you guys have done with it.
That is the magic of Jerry.
Very nice, very cool. All right, any questions before we wrap up this session? All right, I'm not seeing anything else. Guys, thanks so much for joining us. Great presentation.
Thank you, Jeff.
And
hey, Jerry, one more thing here real quick, if you don't mind.
Sure, go ahead.
You're going to run a max T and show the PDF?
Yeah. You know, one thing I didn't really mention that I just wanted to hit really quick, you know, you have certain variables that you can look at and get a really quick understanding of the overall model space. I think one of the first things I do every morning, honestly, is I come in now that I have this PDF and capability, and I'll run max T or min T for the next 7 days, and just give me an idea about where the models are starting to get some differentiation. So I was just going to run that. I actually haven't run it yet today. I came in right away and started working on this thing. So we'll take a look.
Yeah, and this is a great way to kind of, especially if you're coming in cold, you haven't worked in a couple days, and you just want to get a lay of the land where all the guidance is at. Visualizing the PDF here is a great way to do that. And Jerry had we just lucked into that great example that Jerry had in his presentation from last week, where we had instances of a good tight PDF on a day one to flat, kind of spread out distributions a couple days later, and then bimodal and skew. And springtime is obviously good for that kind of behavior. And that was a great example. So yeah, go ahead and maximize that. All right. So yes, what are you seeing, Jerry?
I'm seeing some pretty tight distributions, actually.
I think that's Easter Sunday.
This is Easter Sunday here, so I mean that's what, a day 4 forecast, and it's pretty darn tight.
32 models. And
we might have 1 or 2 models hinting at a little bit warmer solution. We also have some skewed distributions in here. This purple is skewed, so there's probably a model out in here
left skew.
that is, you know, maybe an outlier, and you know, you can, even with ModelCertainty, go in quick and blow that away and say, hey, I don't want to see that model, and it would probably have a pretty big impact on that particular day. And you know, this blue line here, that's a bimodal distribution. So you have maybe a cluster of models on the cold side, 57, 58 degrees, and then another cluster up here on a little bit warmer solution of 63 degrees. So, you know, it's just a really quick thing where you can start to see some of these instances. I mean, this is obviously one here that would jump out at me. This black line here sort of jumps out at me, where there's some pretty good spread in the models, all the way from, you know, say 50 to 60 degrees.
Yeah, so that's next Wednesday, so obviously there's quite a bit of spread. But you can start to also think about this from other variables. I mean, imagine a relative humidity plot.
Yeah.
If you were looking at fire weather sensitive type information or wind speed, you know, you just can go down the line and really you can start to think about ways to visualize this information, and then it keys you in on, okay, you know, the data is looking pretty tight for, you know, Thursday, Friday, Saturday, and Sunday. But, you know, it looks like we have some spread. Now, in the future, does that mean we edit something? Probably not. But what it does allow us to do is it goes and it allows to tell us, folks, okay, look, you know, once we get to next Wednesday, we have a tremendous amount of spread, so our confidence is lower. Our confidence in the solution is lower. Confidence for Sunday, looking pretty high right now based on the distribution. So we can give people a nice tight range. That's where Jerry goes back to the confidence interval. I'm going to make this up and say our 80% confidence interval, just looking at this eyeball-wise, is what, 67, 68 to 72. But we can go back and take a look right at that, at the plan view, and we're looking at Sunday, I think. Yeah, go back over. Yep, over, one more, there you go. And then look for the CI right there. Go down, right there. Cancel that out. And you can see our confidence interval is 5 degrees over, 4 to 5 degrees over our western areas. As is typical for the lake, it's a little higher. So you can also go, maybe I need to take a look at what the distribution is, what the PDF is along the lake versus more terrestrial where they're not as influenced by the lake. And you can see the different shapes of the PDF and where uncertainty is the highest. And then be able to give folks the numerical one. So if you look at, say, Madison, our 80% confidence interval is for a high between 70 and 76. Pretty darn good day. Considering the winter we've had and the spring so far, I'm looking forward to that. But looking at, say, the lakefront, you have a range of 56 to 65. Obviously a larger spread, lower confidence, all depends on how we handle the lake breeze if there is one, or what lake fluence there will be if there is one. And we can then communicate it based off the PDF and based off of that, rather than believing or needing to actually make a particular edit to a particular forecast. And I think, Bruce, that's what you're alluding to, is the future is trying to use this information to explain the variance, to explain the outcomes, rather than to alter a deterministic forecast. So interesting future we're going to. It's an exciting future, and I highly recommend everybody using this tool to just get their hands in the data, get their hands dirty, work with that information, learn more about stats, refresh your stats knowledge, learn more about percentiles and probabilities and PDFs and things of that nature, and you're going to be more comfortable as we get into this this realm. And with that, Jeff, unless there's any other comments or questions, I think we can wrap it up.
All right. Thanks again, guys. I haven't seen any new ones pop in, so unless there's anything here right before we wrap up,